Good morning, welcome. My name's Jordi Clotet and I work as a product manager in Panasonic, and today we're going to present the experience in a hotel using aerothermal heating and thermetics with a project developed by Panasonic and Lobby Group developers. It was carried out in Basa de la Mora in Zaragoza, 165 property, the first phase, 81 properties on which we focused our study, and 84 that were subsequently built. This is the first vertical multi-home building with passive house certification with active load certified in Spain. Passive house was developed in Central Europe, and the main objective is to conserve thermal loads in winter. However, when the standard was transferred to countries like Spain, the conservation of thermal loads penalizes us in the summer due to the more aggressive summers in many parts of the country, prompting the need to use negative loads such as aerothermal heating and also underfloor heating and cooling, or air treatment services and systems that are incorporated with heat exchangers. The first phase of this project, Lobe used the Panasonic Aquaria system, a water battery, and also underfloor cooling for all of the apartments. Before addressing the study, it's important to clarify that the aim here is not to establish a dogma applicable to the whole of Spain, but rather provide guides for buildings in Zaragoza with extremely low temperatures in the winter and high temperatures in the summer. And in Basa de la Mora, we're talking about a vertical building, multi-homes with apartments, and in this case we can extrapolate the study. But obviously, if we're talking about different types of dwellings, then the things would change. A technical cupboard was installed on the balconies containing the exterior unit and the interior unit for aerothermal heating, and also element number 3, which is the heat exchanger, and also for post-treatment of the air, which is the water battery. Within the homes or apartments, there was also underfloor heating for the summer. The water battery does what's shown in this diagram, detailed here. On the left you can see the installation, and on the right shows what happens when the battery operates for heat recovery, up to a peak of 45 degrees, reaching a total of 50. The black line shows what the heat exchanger does, which is to, let's say, lower air intake in the property, 30 degrees, and finally the water battery, which achieves those 30 degrees down to 25 degrees or 16 degrees for the incorporation of cooled air, renewed air in the property. The doubt addressed in the study is whether the water battery was necessary or not, and whether the underfloor cooling could operate on its own with the thermal loads in the summer in a place like Zaragoza. After completing phase 1, 2 similar apartments were chosen, 2 attics, 125 and 105 square meters with similar thermal loads, and one, it was 617, number 17, the first showroom, the water battery was disconnected. In the second, we maintained the water battery and the underfloor cooling connected. Measurements were taken using the Aquaria Panasonic system, which can be connected to internet and allows us to remotely take data for shading, for shade, and the 2 apartments were compared on the 29th, 30th and 31st of August and 1st of September, where we can see exterior temperatures which achieved peaks of 45 degrees during the day, and at night we can see it was a hot summer because the temperature dropped to around 25 degrees. So there was another opportunity at night to refresh temperatures in the properties. The yellow line can be ignored because it only shows hot sanitary water consumption. The red line is interesting, corresponds to the underfloor cooling with 18 impulsion. In apartment B, with only underfloor cooling, it works at 7 and 10 degrees, which is when the water battery demands. The underfloor cooling is taking advantage of this, and there's no need for aerothermal heating to produce 18 degrees, or aerothermics to produce that temperature. It's the temperature that the water battery would operate in the case of demand. Taking into account the difference in surface area, which was 16% between the 2 apartments, demand was greater in the larger apartment. As you can see here, 21%. But energy consumption was slightly lower in that apartment, and when we look at consumption per square metre, we can see that it's 20.4% lower in the apartments with underfloor cooling, 22% more efficient. So, without trying to extrapolate this example to all of Spain in conditions with climate similar to Zaragoza and the type of construction in Basa de la Mora, we can avoid the battery. In phase 2 it means less extraction costs, fewer material costs, better efficiency for final users. Importance was attached to the design of the equipment and the analysis performed. The work between architects and engineers is key, and the Panasonic Aquaria system is clearly an excellent solution, a key to achieve this. Thank you for your attention, and I would also like to thank Clara Llorente from the Lobe Group and the Panasonic department for their collaboration. I hope it's been interesting for you, and please, there's my contact details if you would like further information. Thank you.